Today, we're diving into a really fascinating concept called the OPHI framework. It all kicks off with a pretty simple idea, but trust me, we're going to take a journey from something we all kind of understand, computer code, to something way more abstract, the actual mechanics of a shared reality.
Okay, so look at this. On the left, you've got a line of code. Simple, right? We know exactly how to compile that, how to turn it into a program that prints hello world. But then you look at the symbols on the right. What in the world are those? Well, they stand for a much bigger, much stranger question. What would it take to compile not just code, but abstract meaning itself into a stable, shared reality? That's the puzzle we're going to unpack.
So, to even begin to wrap our heads around compiling meaning, we first have to get on the same page about how we compile code. At its core, a regular compiler is like a logic crystallizer. It takes our abstract human thoughts and turns them into something a machine can execute perfectly, every single time.
And it's not magic, you know? It's a process, a pipeline, with a bunch of different steps. Your nice human-readable code gets broken down into little pieces called tokens, then organized into a tree, it gets translated, optimized, and finally it becomes raw instructions a processor can understand. The key thing to get here is that each step is just a translation, from one symbolic language to another.
Okay, so if a compiler can do all of that for code, what if we took that basic idea and applied it to something way more fundamental? Could a process like that work on our ideas, our observations, on meaning itself?
This right here, this is the big what if. This is the question that the whole OPSI framework is built around. It's proposing a kind of conceptual compiler, but not for Python or Java. A compiler for interpretation. A system that could take in raw, messy data from the world and transform it into an interpreted reality.
And this is the engine that would sit at the heart of that compiler. This is the omega operator. The equation looks super simple, but it is the absolute core of this whole thing. It defines the fundamental act of observing and interpreting as a mathematical process.
So let's break it down real quick. State. That's just the raw data, the world as you measure it. Bias. That's the unique perspective of whoever's doing the observing, their personal filter. And alpha, think of that as the context or maybe like a gain control on a stereo. You put all those together and you turn that raw state into omega, a single, unique, interpreted reality.
But here's the thing, right? We don't live in a world with just one observer. We live in a world with billions of them. So what happens when you have lots of observers all doing this at once? This is where the framework blows up from a single little equation into a whole network, which it calls the mesh.
And to make this feel a little more concrete, the system actually gives these observers names. They're not just numbers on a spreadsheet. They're agents in the system. You've got Ash, Nova, Graviton, and each one is running its own omega calculation. They're all looking at the same state, but each one has its own bias and alpha.
And the result is, frankly, brilliant. You don't get one single answer. You get a cloud of interpretations. And this diversity, this disagreement, it's not a bug. It's the whole point. It's the raw material for the system. But it does create a huge challenge. With so many different viewpoints, how do you stop the system from just flying apart into chaos? This is what's called drift.
And here's a perfect example of what that looks like. You've got Ash and Aya, and they're pretty much in agreement. Their interpretation is hovering around 1.0. But then you have Nova, who's way out there at 1.40. In a less sophisticated system, that one divergent node could literally pull the entire consensus away from a stable agreement.
So, how does the system deal with this drift? How does it take that messy cloud of interpretations and forge a single, stable consensus? Well, it introduces a really elegant solution. You could call it a guardian of order.
It's called the SE44 gate. The best way to think about it is like a quality control checkpoint for reality. Its entire job is to look at that whole cloud of interpretations at any given moment and just decide, is this stable enough to be considered real? It acts as a kind of phase lock validator for the whole network.
And it's not just guessing. The SE44 gate has 3 incredibly strict, non-negotiable rules it follows. First, coherence. Are the observers mostly in agreement? Second, entropy. Is the signal clean and orderly, or is it just noise? And third, RMS drift. Is the consensus stable, or is it wobbling all over the place?
So it's a simple pass-fail test. If the state of the network meets all 3 of those crazy high thresholds, it gets a pass, and it's sent on to something called the fossilizer. If it fails on even one of those metrics, it gets rejected and shunted off to a mutable shell, basically a temporary holding pen where it isn't considered part of the official record of reality.
So, what happens to all those states that do pass the gate? Where do they actually go? This brings us to the final and maybe the most profound piece of this whole architecture, the creation of a permanent, unchangeable history.
Every single one of those validated states is sealed up and chained together into what's called the Merkle fossil ledger. And the language here is really specific for a reason. It's append only. You can only add new moments to it. You can never go back and change the past. And it's tamper evident using cryptographic hashes, just like a blockchain, to guarantee the integrity of the entire history.
And if you could crack open one of these so-called fossils, you'd find everything you need to prove it's legit. You've got the block number, the timestamp, the hashes that link it to the block before it, and this is the crucial part, the exact coherence and entropy scores that proved it was good enough to pass the SE44 gate in the first place. It carries its own proof of validity. Which brings us all the way back around to the framework's absolutely stunning conclusion. After building this entire system, from that first omega operator to the mesh, the gate, and finally the ledger, we land on this definition. Reality isn't some fixed external thing we just measure. In this system, reality is the stable, validated, and recorded consensus of all of those observer interpretations. And that leaves us with one last, really provocative thought to chew on. The whole system is designed to find and record stability. But if a shared reality is just a stable consensus, what would it mean if that consensus were to fundamentally and permanently shift? What would that even look like?